All right, we are back on Wednesday, April 22nd, and today we're going to start solving exponential and logarithmic equations. So here's our first set that we're going to solve. One thing that you need to make sure is you are checking for extraneous solutions. You always need to check log equations for extraneous solutions. So we will be doing that. All right. So on our first one, we have log base 4 of 2x plus 8 equals log base 4 of 6x minus 12. Well, I have one log on the left equal to another log on the right. So it's almost like I can take those logs away and I have 2x plus 8 equal to 6x minus 12. Okay, I just set up what they have equal to each other. And now we solve. Subtract 2x. So 8 equals 4x minus 12. Add the 12 over. 20 equals 4x, divide by 4, and x turns out to be 5. Now what I mean by checking, I can never have a log of something to be negative in here or negative in here. So 2 times 5 plus 8 gives me 18. And 6 times 5 minus 12 is 30 minus 12, which gives me 18. So both of these are positive numbers. That means my answer is 5. Let's try another one. Okay, on my second one, we have the natural log of 7x minus 4 equal to the natural log of 2x plus 11. Since I have natural logs on each side, I'm just going to make these equal to each other. So 7x minus 4 equals 2x plus 11. Subtract 2x over. 5x minus 4 equals 11. Add 4. 5x equals 15. Divide by 5. And x turns out to be 3. So now we need to make sure that these are not negative right here. So if I put in a 3, 7 times 3 minus 4, 21 minus 7 is 17. Ooh, what is that? And then 2 times 3 plus 11, 6 plus 11 is 17. X equals 3 is our answer. All right, not too bad there. That's very nice when you have one log on the left equal to one log on the right. Oh no, we only have one log. So whatever shall we do? Well, remember back when we could take a log and change it to exponential? If you only have one log, you are going to change to exponential. And remember, we always have to check our answers for extraneous solutions. All right, so on our first one, we have log base 7 of 3x minus 2 equals 2. So how would I change this to exponential? Well, 7 squared equals 3x minus 2. So that gives me 49 equals 3x minus 2. Add 2 to each side. 51 equals 3x. Divide by 3. And x turns out to be 17. So now we need to check. if I replace in here my variable with 17, 3 times 17 minus 2, that gives me 51 minus 2, which is 49. It's positive, because you can never take a log of a negative number. My answer is x equals 17. All right, our second one. The natural log of 5x plus 4 equals 3. All right, I only have one log, and that is a natural log. So what is my base? What is the base of a natural log? Well, the base of a natural log is e. So e, right, to the third equals 5x plus 4. Well, I'm not going to put e in my calculator yet. I'm just going to subtract 4 from each side. E to the third minus 4 equals 5x. Divide by 5. E to the third minus 4 all over 5 equals x. Now, here's where we can approximate. So you put everything in your handy-dandy calculator, e to the third minus 4 divided by 5, and x turns out to be approximately 3.22. And if I put 3.22 back into my variable, 5 times 3.22 plus 4 is going to give me a positive number. So that is my answer. In some cases, if they want, this would be approximate. If they want exact value, you would just leave it in that form. If they want an exact value, you just leave everything in that form. All right. Now, you notice this one's a little bit different because our variable is in our base. Our variable's in our base. And I still only have one log, which means I'm going to change this to exponential. So my base is 2x to the third equals 8. 2x, I have to put that in parentheses, to the third equals 8. Well, now remember, I have to take everything to the third power there. So 2 to the third, x to the third equals 8. 8x to the third equals 8. Divide each side by 8. X to the third equals 1. And to get rid of a cube, I would have to cube root each side. So x equals, what is the cube root of 1? It is positive 1. Again, you need to check because I cannot have a negative number right here either. So 2 to the first is positive, so x equals 1 is our answer. And then our next one. Here's our base. 2 to the second equals 16. So x minus 3 squared equals 16. Here's where a lot of students make mistakes. They just square the x, square the 3, but we cannot do that. We have to write it twice. And then FOIL or double distribute, however you know. So I get x squared minus 3x minus 3x plus 9. First, outer, inner, last. That leaves me with x squared minus 6x plus 9 equals 16. Since I have an x squared and an x, everything has to be on the same side, so I'm going to subtract 16, And that gives me x squared minus 6x minus 7 equals 0. Guess what we're going to have to do there? We're going to have to factor. Okay, I know there's an x and an x. What times what is negative 7? That adds up to be negative 6. Well, that'd be negative 7 and a positive 1. Then I set each of those equal to 0. X minus 7 equals 0. X plus 1 equals 0. Here, x equals positive 7. X equals negative 1. So now I gotta check it. And we're gonna check with yellow. Here we go. So this is what I have right here. So I have 7 minus 3 equals 4. That one works out. There's an answer. Negative 1 minus 3 equals negative 4. I cannot have a negative base. So that right there is an extraneous solution. So my only answer is x equals 7. So don't forget, anytime you have an x squared and an x, you may have to factor. And you will have to on your assignment. So make sure anytime anything looks like this, you have to factor. Hint, hint, hint. All right. So that is all for the first day of solving logarithmic equations. Don't forget, if you have any questions, your teacher is the best person to go to. They have office hours. Get a hold of your teacher, ask them questions, and have a great day.